So, welcome to Ce488 Environmental Geotechnics interaction number 14, and before I go into this, just a quick recap of what we have been doing in the last lecture. We have been talking and discussing about the material characterization, geomaterial characterization, and I had given you a comprehensive list of what are the features which you would like to understand before creating a strategy for a material to be designated fit or suitable for a certain utilization scheme. So, before I venture into this, I have to take a question which has been asked by the student in the class, and this question is by Krishna. The question is that how do we assess and mitigate ground settlement caused by tunneling? So, I think this can be deferred for the time being because I am not teaching you a course on tunneling technology. But a quick answer is that you should do a proper instrumentation for understanding that how the deformation and caving in of the tunnel walls are taking place. So, we normally use different types of extensometers, and there are different types of profilometers which are used to study the deformation patterns of the tunnels. And I am sure this question must have come to your mind based on the recent accident which has occurred. So, this is where the role of geotechnical engineering becomes very important in understanding what type of shear zones exist in the rock mass or the soil mass, and their proper characterization is extremely important. So, I am not going much into details of tunneling, being a different subject altogether. Better read and practice and visit the sites where the tunneling operations are going on. The second question is what are the effects of earthquakes on the tunnels, and do we design for seismic resilience? Yes, of course. So, when you design the tunnels, you take into account all sorts of stresses and the forces which are acting on the systems. But the major force is the seepage, which cannot be done away with, because seepage is the biggest culprit of underground structures, particularly tunnels. So, that is a very important thing, and of course, earthquake loading can be taken into account very easily. That is not a major issue. So, now let me move on to our discussion on the geometrical characterization. And we have been asking this question, why geometrical characterization, and I tried to give you some answer in the previous lecture, that what is the importance of characterizing the geomaterial. The basic intention is to utilize it in the right appropriate manner, and particularly in today's world when everybody is talking about sustainability and green structures. Okay, this is where everybody is trying to utilize the unwanted material, so called waste, which is lying here and there in the vicinity. It could be industrial, it could be municipal solid waste, it could be anything which comes out of any industrial process or from the municipality, and hence it becomes very important to understand how this material is going to behave under a given circumstances. Circumstances are very important. A good example of circumstances would be when you do shearing of the material. Slow test, fast test, drained, undrained, which you have discussed in the past. These are all circumstances where you are trying to simulate what happens to the dissipation of the pore pressures because of a certain type of loading or unloading. All right. So, circumstances are very important, and how this material is going to behave under a given pattern of loading, that is normal stresses, horizontal stresses, shear stresses which are acting on the material or within the material. So, this is why it becomes very important and crucial to understand how geomaterials are going to behave. Present day idea is to understand how THMCB is going to act on this material. The whole emphasis of environmental geotechnics is we are several steps ahead of conventional course, environmental geotechnology. Uh, in the genesis being in geotechnical engineering or soil mechanics, but normally what we talk about is the type of stresses and the forces which are acting on the systems or the geomaterials are different types. And I have been emphasizing repeatedly the role of hydrothermo, mechanical, chemical, biological processes which are occurring in the soil mass, rock mass, groundwater, and how do they influence the overall structure. So, this is becoming a more and more realistic and more important discussion considering the present day subject. And I have cited several examples in the past, all right, CCUS, CCU, and geothermal engineering related issues, and even municipal solid waste is a beautiful example of where THMCB is going to occur in the material, which is waste material. So, when we talk about this, the simplified version would be thermo-hydro-mechanical models which have been used in geotechnical engineering, waste disposal, design of buffers, covers, liners, thermal backfills, multi-phase geomaterials, which we have discussed so far. And all these tests or the attributes have to be estimated to understand how the material is going to perform ultimately. What is that is important here to understand is that all these traits or the properties are going to control the overall geotechnical or geoenvironmental properties or the response of the material in the long term and in the short term. So, you must have studied drain undrained loading, which is a good example. So, drain loading is going to be a long term phenomena, all right. Slow drainage taking place because of the hydraulic conductivity being very small. So, the second yearites you will be doing these things in the third year, or I do not know whether you are studying it in this semester or not, but anyway you will have to wait for the proper time to arrive when you will be trying to understand the response of the material over a prolonged duration or a quick response like earthquake. So, when earthquake comes, structure does not have much time to understand how it has to behave, all right. The impact is so quick, and whatever happens is in fraction of seconds or in few seconds. So, this is a quick system, undrained. Material does not have much chance to expel out or dissipate the pore pressures, all right. And the long term is a slow process where the drainage occurs. Construction of dam is a beautiful example of a drained system. Why? Because first of all, construction of dam takes a lot of time, few years, and each layer you are rolling and compacting, and you put a filter media also. So, when you are rolling, compacting, the pore pressures develop and they get dissipated, fine. So, these are the good examples of how long term, short term phenomena can be classified. Another thing would be most of the processes and the mechanisms which we are talking about are time dependent. Even hydraulic conductivity is also time dependent. Why? So, in conventional geomechanics, we do not talk about the material degradation, but here we talk about material degradation because of thermal effects, because of chemical effects, because of biological effects, and hence the state of the material keeps changing every moment. The same is the case with CCUS. You are injecting carbon dioxide, even gas hydrate formation, because these are all kinetics related processes, where the process is happening as a function of time. So, how much gas is being occupied in the space or the void space of the porous media under a particular pressure and temperature condition, and what type of chemistry is getting actuated is the major question. That is what we want to understand. So, I hope you are realizing that this is slightly a complicated realm of what you have been studying in the conventional soil mechanics and geotechnical engineering, but then this is the order of the day. These are the problems which are forcing us to think otherwise. So, let me move ahead And let me talk about the geotechnical characterization. As I discussed in the previous lecture, the first thing is the physics of the material. The physics of the material is its physical attributes, texture. You take the soil mass, rub it in between your fingers or the palm, you know what type of texture it is. It is smooth talcum powder which you use for your skin nourishing, all right, or the lotions which you use for rejuvenating your skin, or if you take sands and if you rub the sands, you realize that, well, this is something, you know, which makes noise also, there is a friction also, and then if you press this too much, the chances are you may cut your fingers also, because this is quartz, and quartz is the mineral which has a very high crushing strength, but it cuts also if the edges are very sharp. So, when we talk about texture, texture deals with morphology. Morphology is the technical term, where we try to understand shape, size, you know, any important feature on the particle. Why? Because, so suppose this is the grain of the soil, all right, highly irregular. Now, intentionally I have drawn like this, otherwise I could have drawn a perfect sphere, and this is how you study normally the soil mechanics, by assuming soil mass to be a granular structure, which is not the real case. Anything which is smooth is bound to give you very low specific surface area as a thumb rule, all right, very small specific surface area. When specific area is going to be very small, its reactivity with the environment is going to be extremely small. So, if I say environmental reactivity is going to be very, very low, passive materials. Okay? But what nature does? Nature is very intelligent. What it does? Many times it coats something on the top of this. Clear? So, this is a pure quartz. Now, under the action of pressure and temperature and the type of bacterial activities which you are having in the system, the chances are that this may get changed, and one of the structures could be like this. At some of the sites, maybe the quartz has been eaten up. Why? Because this pressure, temperature and biological conditions create a pH which is not very conducive for the quartz to remain as it is. Fine? This is one example. The second example is bacteria might create MICP, if you remember. So, MICP is microbially induced calcite precipitation, and what may happen is on this surface you might have a coating which is done by the bacteria. This is what MICP is. Everybody is talking about microbially induced calcite precipitation on the grains. Now, what has happened to the surface area? Initially this was a rough surface. Any rough surface will have SSA very high, specific surface area. Why? Because it is not a smooth surface. There are many, undulations, cracks, many types of cavities and so on. So, what you require is, you require a scanning electron microscope to see how this system looks like. So, most of the time people take out grains of the soil and then they do microscopy to understand what type of particles are these. Clear? Now, if I am a jeweler, if I am dealing with the minerals, clear, precious minerals, what I am supposed to do? If I have to increase the solubility of this mineral or this mineral, I have to shape it up properly. Shaping it requires cutting, grinding and so on, the way the diamond is done. Clear? So, what nature does is, and what human beings can do is alterations. So, specific surface area is very high, environmental susceptibility is also going to be very high, or reactivity is also going to be high. Now, this is what becomes a chemically activated, bacteriologically activated system. Are you realizing what we have done from the initial inert system? We have created a bacteriologically, chemically active system. Now, where I am going to use it? So many industries are looking for this type of answers. Clear? This can become a beautiful zeolite, molecular sieve. It can become a beautiful catalyst. So, this might act as a catalyst. Got the point? A simple coating on the top has done all the wonders. So, when you design swimming pools or the filters, you take the granular material and then you allow coating of bacterial activity to take place on the top of this. What this bacteria is doing? This gives you much more clean water by digesting all the sorts of organic impurities which are present in the water. So, this becomes a activated filter material. I hope you are realizing the whole thing. So, very simple looking term, texture, clear, morphology, but when a technologist deals with all these adjectives, what happens? So much is the interpretation. Got it? These are beautiful examples which are being used in day-to-day life to deal with the minerals or the soils and their activation and so on, depending upon what is that you want to do. As far as the particle shape is concerned, we do particle size distribution, and there are different equipments which I will be talking about, which are all laser spectroscopy, which will tell you about the morphology of the particles. So, there are scanners, laser scanners, all right, where you can keep the sample and then you can find out based upon the laser diffraction whether the particle is needler, elongated, all right, flat or whatever. There are different type of stereoscopic examination also which you can do. So, this plus 2D and 3D imaging is normally done. So, many of you who are looking for AI, ML applications, I hope the ground is set. What do you require? You require a camera, electronic eye, and what electronic eye is going to do? Electronic eye is going to differentiate between the shapes of the particles. So, you define a system where you can segregate the particles based on some imaging process. You can take out this type of material separately, this type of material separately, segregation is done, use them in the industry. Yes, please.
In the MICP layer, is the bacteria present in the layer or like in the whole system?
This is the precipitate. So, this is microbially induced calcite precipitation. So, what bacteria has done is, bacteria require some nutrition, clear? So, you add some nutrition, some ammonium salt or some sodium salts or some nutrition, correct? Plus add some water. This is what is known as different types of activated solutions like agars, or what is the name? What do you call them? Agars or agars? Agar is nothing but if you take milk and split it by adding few drops of lemon, what happens? It splits. So, the suspension settles down and you use it for making cheese and paneer and all this. Whatever the liquid is, people say it's very nutritious. Why? Because this has all the bacteria which got suspended into the liquid form. If that solution I take out and if I mix it in the soil, clear, and I add some bacterial activity into it, bacteria will multiply. So, what it is going to do is, it is going to produce calcite. Calcite is nothing but your calcium carbonate. Got it? So, this calcium carbonate is going to get precipitated on the top of the grains. This is the mechanism. Many people have tried doing this. The biggest challenge is how to take it to a bigger level, industrial level. Okay? So, there is a beautiful discussion going on right now that how MICP can be utilized to overcome the sand dunes migration and The dust storms, very latest topic. Read it. I am sure I have shared, I think, 2 videos also. So, how to mitigate the dust storms? Anybody from desert areas of the country in this class? I think you can realize there is a big problem. Is it not? So, when these dust storms come, what happens? You can't even breathe. So, one of the groups is trying to work on, including Dr. Surendra, he is trying to mitigate dust storms. Imagine all the troops which are positioned where? On the western borders of the country. And if dust storm comes, can you breathe? So, this has become a very big issue. So, I think one of the solutions would be MICP. Read more about it. Now, this has to be taken up at a commercial scale. Fine. So, we do 2D, 3D imaging to understand what is the particle size, shape, its morphology and so on. And ultimately, where do you use this concept? You can use this concept in defining whether the sands will liquefy or not. Liquefaction of sands. I hope you are realizing I am venturing from one end to another end to another end to another end, correct? Why? Because these are the applications. Ultimately, I want to design the building foundations on liquefiable soils. How to mitigate this liquefaction? One of the process would be this. I am binding the particles. So, this is very important. Number 2 is specific gravity. I hope many of you understand, you have done this experiment. Specific gravity happens to be a fingerprint of the mineral. You define it as GS mostly, specific gravity of the soils, correct? So, this is an indication of the mineralogy. Why? Each mineral has a specific value of specific gravity, including the organic matters also. So, today's geomechanics and environmental geomechanics is mostly heading towards organic matter. Why? Because the waste which you are producing is mostly having organic matter in it. Okay? So, what this organic matter does? Organic matter is lighter material, mostly cellulose. What is going to do? It is going to drop the value of GS tremendously. So, the system is going to become very light. So, a question which concrete technologists would ask you is, out of the particles which you have given them, out of the waste material which you have given them, whether it can be utilized in concrete or not, whether it can be utilized for some purpose in concrete or not. So, one of the indications would be GS. Simple test, take the sample, find out its mineralogy, correlate it with the specific gravity. Specific gravity is very easy to find out and see whether these two are matching with each other or not, getting correlated or not. And this will also give you an idea about organic matter. The more the organic matter, more the problems. Decay will continue for several years. So, whatever structures we are going to make on the soils which are having more organic matter, what will happen? Distresses, settlements, cracking, foul gases emissions and so on. Clear? The more and more decay occurs, chemical process, biological process, temperatures might rise. Beautiful example is landfill. Clear? So, this is the significance of specific gravity which you have studied in your conventional course. Surface area, I talked about the surface area. So, total area divided by per unit weight of the soil mass is specific surface area. And this again becomes a very critical parameter in environmental geotechnology, because when you are selecting the team, selecting the material for your specific applications, unless the specific surface area is very high, I will not use it as a catalyst. Then this goes in the reclamation. If surface area is very high, chemically active material, I can use it for some other industrial processes. There is another school of thought which is working on silica reduction technology. Long back I think I discussed about this. SRT, that means if you reduce quartz, all right, you might become a multi billionaire. Why? Quartz is lying everywhere, soil. Now what I have to do? I have to reduce silica from the quartz and take it out in a gel form. And where would you use silica gels? All your cosmetics, modern day treatment of the diseases. Clear? That's it. Read the applications about silica gels. Now this silica gel is also important for giving the strength to the material. Because when gelation occurs, then only strength mobilizes. So this is a bonding between the two particles because of the amalgamation of the silica. I hope you are realizing the whole matrix is like this. Fine. Then we have void ratios, porosities, then we have degree of saturation, water content and all those things which you have studied. Then we talk about the compaction. Remember, each of these terms in English is truly speaking an indicative of the material. The compaction curve which you have plotted gives you a quick idea about the type of the soil, its classification. So the tests which you have done knowingly, unknowingly are the tests which are normally done to characterize the soil mass. Clays cannot be compacted, silts can be compacted, sands cannot be compacted. Got it? So if I show you typical results, you can make out that this material appears to be like this based on its compaction curve. Void ratios, very high void ratios, 2 point something, 3 point something marine clays. Okay. Void ratios of the same order, but different particles mineralogy and different particle morphology, desert sands, very high void ratios. So the moment you touch them, the whole thing collapses. Are you realizing the two extremes? The mathematical number remains same, the material changes, the process changes. Then comes your consolidation and compressibility. So truly speaking, these numbers, consolidation and compressibility numbers also tell you about the state of the material. I am sure you must have come across the term CC, the coefficient of compression. Now if coefficient of compression is greater than 1, highly sensitive material, prone to consolidation. Less than very small value, tending to 0, inert material. It's not going to consolidate. It's not clays, must be a sandy material and so on. So these are all indications of, these numbers are indicative of the state of the material. Then comes hydraulic conductivity, which is a combination of all these terms. So the hydraulic conductivity which you have studied so far, defined as K, okay. K describes a lot of things. Now suppose if I say K value is 10 to the power minus 3 meter per second, you have a connotation, correct? It appears to be gravels, sands, okay. Now suppose if I say K is 10 to the power minus 11 meter per second, it becomes a fine grained material, clays. Somewhere in between, combinations of the two. If I say permeability is 10 to the power minus 21 meter per second, what type of material is this? Rocks. Very small permeability. Intact rocks. So I hope you are realizing these English terms change the context. If there is a fracture in the rocks, the permeability could be not through the mineral matrix, but through the cracks. Very good. So this will be very high. It could be very high. depends how the crack fracture patterns are located. So, the question which has been asked in the beginning of the class and we were discussing, when you are dealing with the rocks which are highly fractured, you have to be extremely careful to avoid mishaps. So, the more the discharge of the water inside the cavities is an indication that any time the system might collapse. But it is unfortunate that several tunnels in the country are leaking. So, that is another ignorance or maybe design flaws, you may say. And then comes the shear strength, a very big topic to study. Okay? Shear strength, I think you must have done this in your third year and second year. Are you doing all this? Very good. So, shear strength is a function of time. Do you agree with this? Why? The way it is taught in the classrooms is that shear strength is a permanent thing. Human body is also not permanent. So, that means everything decays because of all these processes. So, the shear strength of the material might depend upon all these processes which are occurring in the system, which are a function of time and making this material lose its shear strength. But at the same time, bacteria might play a trick, and what it may do, it may enhance the shear strength. So, this is your MICP. Did you follow the difference between the two? It depends upon what is that you are really trying to do with the same material. Okay? So, all this comes under the physical geotechnical classification, all right. Then sometimes we do penetration tests. Penetration is also a sort of a shear strength. Mostly shear strength is used for compressive stresses, all right. But suppose if you want to see what is the tensile strength carrying capacity of the material, where would you use it? In most of the systems where the let us say tunneling is being done, the material should be able to take tension on the crown portion, all right. Even if it deflects, it should not fail, it should not collapse. That is another application. So, this is where actually we talk about the tensile strength of the material. And then there are specialized tests to do these tests. To find out this, not tests, there are specialized tests to get this parameter. Had it been a steel wire, what we could have done? We could have done an elongation test, correct? You must have studied in your 10+2 physics also. You take a steel wire, apply stress and then see the deformation and then plot stress versus strain. That gives you the yield stress and ultimate stress and all those things. How to do it on soils? There are techniques. You make a soil sample and then go for a penetration test. So, one of the types of the tensile strength test is a penetration test. Fine. And this gives you an idea about how much tensile strength the material can mobilize. The best possible application of tensile strength of minerals comes in sports pitches. So, this concept I have used quite a lot to define the health of the pitches which are normally made or the turfs, sports pitches and turfs. Why? The tensile strength is the one which governs the cracking of the soils. Cracking characteristics. So, lower the tensile strength, more the cracking. Got it? and cracking is induced because of the environmental forces. So, if you are designing these troughs and pitches, very good. If you are working in the nuclear waste disposal industry, the temperatures are very high. And if you are trying to contain those canisters, if you remember, which were buried in the minerals, the temperatures are very high, moisture will be lost. And once the moisture is lost, what is going to happen? The tensile strength is going to decrease and the desiccation cracks are going to get developed. Material is going to crumble. Hydraulic conductivity is going to increase, loss of strength and so on. So, depending upon in which industry you are, I hope you can realize that the applications are tremendous. Fine. So, most of the time these cracking characteristics are defined as desiccation cracks. The best example of desiccation cracks appearing in clays is what potters do. Have you seen any potter making a pot? You know, these concepts are very interesting. So, a potter making a pot or any sort of a artifact, if it cracks, it loses its value. So, these are the guys who are very particular about treating the clays so that the desiccation cracks due to environmental stresses, which is temperature, pressure, humidity, sunlight, should not occur. Fine. And then there is a term known as collapse potential. So, these granular materials are normally characterized based on their collapse potential. We define it as Cp. I am sure you must have heard of that. Most of the development right now is taking place in the western part of the country, in deserts. Why? A lot of land was available there. Clear? A lot of natural resources are there. Deserts were nothing but lakes once upon a time in geological time frame. So, these are the places where you have most of the oil and gas resources and reserves. So, now the attention suddenly has shifted towards deserts, and in deserts what you find is only coarse grained material, sands, aeolin particularly. Clear? So, this is something which we have ignored since ever. We never talked about what is the collapse potential, and now in newspaper you are hearing every time that climate is changing and there is an impact on the infrastructure which is done by civil engineers. What is happening? All these oil tanks and forms which are resting on the foundations are becoming unstable because they were never designed for saturated conditions. So, collapse potential is something where we talk about loss in integrity of the granular material due to sudden inundation. Inundation is wetting. So, if you see Times of India news and the national network, they are too much worried about flooding taking place in the Rajasthan area since the last couple of years. That is of course climate change. And what climate change is doing? It is influencing the entire engineering practice of designing the structures there. If you get a chance to work in the Middle East, where you will not be having clays, you will not be having silts, you will not be having weathered material, what you are going to have? You are going to have mostly a system of sands. So, the guys who are working in these regions, their definition of classification of the soils is collapse potential. That means, if I plot E versus sigma prime curve, and if I take it from this point to this point, starting from initial to let us say first loading, and if I allow the indentation of water, indentation is pooling up of water. So, this is where the water is inundated. we are simulating something which happens due to the rainfall, there will be a loss of void ratio like this, and then again it will continue. This loss of void ratio is delta E, okay, under sustained loading, and then collapse potential will be defined as delta E over 1 plus E naught, where this is the value of E naught. So, whenever you may get chance to work in the Middle East or deserts which are now going to be rehabilitated, a good example is visit Dubai, visit Abu Dhabi, visit all these countries, Oman and all. Most of the infrastructure is being done over there. So, their way of classifying the soil is this, got it? And they want to understand how much loss in strength is taking place. Okay. So, I will stop here today. Thank you very much for coming first of all. I know you have been quite busy, and this is my class.
Yes,
and
very nice.
yeah, so we have here second year students, so third year, fourth year, PGs, masters, postdocs, PhDs, and of course myself,
Okay.
who wants to learn everything. So, with this introduction of the audience, now I will try to introduce Shri Saxena. So, he is a postgraduate in economics with specialization in econometrics, a law graduate, an MBA and finance specialist from IIM Kozhikode, and with over 30 years of multidimensional experience. So, Mr. Saxena has worked across the sectors ranging from women's empowerment, rural development, to hardcore infrastructure, specializing in policy development and project structuring. His expertise includes policy and strategy development. Actually, this is something which we do not understand much. And project planning, risk assessment, financial structuring, and dispute resolutions, among others. Most of the projects are under litigation, dispute, arbitration, and all. And many of them are doing this engineering law at IIT Bombay, because our department offers this course, engineering law.
Oh, that's wonderful.
Yes, so many of them have done this course, I suppose. And he has contributed in decision making of more than 150 projects worth over USD 9 billion, including Navi Mumbai Metro, Navi Mumbai Airport, and Maharashtra's roads, water and waste management projects. So, this is what actually we discuss in this course, environmental geotechnics, how to develop these type of projects. He has also drafted Maharashtra PPP policy for urban development and first PPP policy for Indian Maritime University. He is an expert member on various committees of the government and government agencies and local bodies in Maharashtra, and a PPP expert in National Task Force on 24/7 water supply Amrit, set up by CHIPO, they call it?
Yes,
CPHO, and MOHA, Government of India. His academic contributions are extensive, blending practical insights with education. He is a guest faculty at IIM Udaipur and at IIT Kanpur, delivering sessions on infrastructure financing, contract management, PPPs, and circular economy in their management development programs. He is a speaker in national and international seminars on PPPs infrastructure and delivered sessions on EU diplomats on waste water frameworks. So, truly speaking, your expertise actually matches extremely well with this discussion which we are doing. And that's what actually I requested you to.
Curious to know whether
Yes.
it is a right blend or not.
Yeah. And a regular faculty at the Comptroller and Auditor General Training Institute. He inspires students and professionals alike to innovate in policy, sustainability, and infrastructure development. He is presently working with ADB and NIIF.
Thank you very much, Doctor, for inviting me here. It's an honor to be here. Yes, and I don't know what is exact course going on, because Doctor once one fine morning or the evening he sent me a message that he is conducting this class till April. Yes. Oh yes, that would be good, because you don't know what I can perform. I don't know what your expectation, but I think I'll try to match, because I thought of I went through some kind of a course guidelines that you are going in. That was while preparing for this session. So there are many things that we keep doing in our personal lives, in our professional lives also, but for a small 45-minute session here, would demand me to do some kind of a work again, so that me and you gel together for next 45 minutes. Otherwise, it will be of total waste. I may be an expert on certain things which would be of no use to you. It's a waste. And I may be a common person, but we connected together well. I think that would be the best thing that we can adopt. So connecting involves interaction. Interaction involves more curiosity from both of us. Okay, me knowing what you want to know, you know, and you expect me to deliver what you want to know, or something other than that also. We can always take a small diversion, understanding if I am doing something exciting or if you are doing something exciting. So first, what is it that you expect from this 45 minutes? I am totally blank. What Doc Saab has told you, what kind of a session this is going to be. So you please appraise me. This I have done in the blind, like when you play cards and you just play blind, and most of the time you don't, when the bets are higher, you don't have the courage to pick up the card and see, okay, agar मैं देखूंगा तो मैं चल नहीं पाऊंगा. So you do a blind show. So that's a kind of a blind show here. So let's see that blind show.
One question I have to ask
Yes,
you.
yes.
Would you mind getting this thing recorded?
Oh yes, no problems. No problems. I am not. Oh yes, please do. It's an honor for me. So that's not a problem. Yes, because I'm not doing it under any institution or this thing. I'm on my own for the past so many years. So I have no this thing. This presentation is all available to you. Just remove my name and do whatever you want. So don't worry on these things also. So this is a research data when it comes to findings and the facts, because if I have included some projects, so definitely I have not done many projects that are included here, but yes, then I have to research. What is the expectation from all of you? Project planning, yes, I included from the point that, okay, what is it that we can understand while we are discussing geotechnology, environment and sustainability and the project development, okay. And when I say project development, when we do planning, we are project people, okay. I have advised the governments of many states and the central government on structuring the projects which are commercially viable, okay. This term is very important, because if you do any policy which is not commercially fit, it is going to just be an academic paper, because the people will not use it, because there is no commercialization in that. And commercialization not in from the bad aspects that everything is want for the money. No, you require money to study here also, okay. Till the time we have the required amount of money, we just can't move forward in our life. So money is required. Earning money is not a sin. Money is required to sustain. That's the first thing. Now sustaining in the environmentally friendly thing which may add to the cost while structuring, that's where the planning comes when we start discussing the environment, project, concretization, then again sustainability, environmentally sustainability and commercially viable. So yes, I think you all are from the geotechnical. Environment is a sub branch of civil engineering. Okay, some good encouragement, because that's where I belong to. I am not a technical, I am not a civil engineer, none of my, yes, good dogs. So that is very good. Okay, anything apart from this that you would expect me to deliver? Any question that you may ask, you may like to ask, which should be answered, and the same question can be repeated at the end, and we can see whether some understanding has improved or not. Anything that you want to know?
I think it will come extempore.
Okay, no problems. So, do we have the? अच्छा नहीं है, नहीं रहने देते. So my thing is, till the time, the same thing I repeat, till the time economics, finance that comes into the project planning or policy making, this is not going to stick. So everything what I am trying to deliver today, it is actually how this can be environmentally safe, and at the same time it is commercially viable, and how to make it. That was for some posturing. Back at home, They want everything to be considered in a manner that it should save the environment, and that's how if you want. So how to save? So it means that there was something going into the environment polluting. So there are pollutants. When there are pollutants, it is going waste. How, if we can somehow capture that waste and put it back to the, so we are doing a policy would be done how to contain the pollutants. There are two ways. One is that I don't produce anything, means I don't manufacture those things which are creating more pollution and having more pollutants in the environment. And the second is that I will do something which will contain. So till that time, there is nothing which, no word in my this two sentence in the last 1 minute has come selling. So it is only either I am stopping again, like I am not producing, and then it means lesser sale, it means lesser revenue, it means lesser economy. Okay, it's all direct. And the second is contain. Contain is that whatever is going in the air, I should put certain equipments which will contain, or I should put certain equipments in the process, in the furnace or somewhere which will contain. Again a cost, adding to the cost. There is no revenue which is coming in. This if we keep doing, we will be doing only cost, and there is no sustainability, and the consumer would be entrusted with, or the cursed with more cost, the prices would be higher. So the thought came, how can it be, can we do something which is like whatever is contained can be reused, and that's where the concept of circular economy. Anybody can tell me, just for my encouragement interacting with you, what is circular economy?
Waste produced from a specific industry
Yes.
to be utilized as a product in some other industry.
Very good, perfect. And that is what is net zero. Because a waste of one industry is used as a raw material to create the product of the second industry. So that product is sold. Now for the first time, the term selling, sold, and realizing money from the waste has come in. Now, where all we, and then this class is civil, structures, soil, rocks, waste, all those things. So natural resources. So this class is okay, yaar. Where am I? If a gas is emitting, I am the civil structure person, I am doing the structures. So can we do something that blends both the objectives? The objective we cannot do. Nobody in the world, nobody in my family, nobody in your family would do something or would stop doing something which is earning bread for me or which is earning bread for your family. You would not, irrespective of whatever is happening. They say, you are doing something which is creating some kind of a noise and I am not able to sleep. So I'll fight case. But if it is an economic activity which is earning bread for my family, I'll not stop. At the cost of life, he is saying it's a sound pollution. So what? It's a life and death question for me. If I don't do, what will I do? Okay. Automobile. So any sector you pick up. So we'll try to stick to the construction industry because you all are there. So let's say if I am doing something which is creating pollution, what is the best way possible? And the pollution is to be contained. What is the best way possible? Stop something, not produce pollution, or control the pollution, or use something out of that and reuse it, put to the better use and start getting something more commercial or financially viable thing. Anything that you would like to tell me of any sector that comes in your mind, of any activity, I will not say sector, any activity that comes in your mind when I am doing this thing, that yes, there is a production which is going on, okay, and then there is this the pollution which is coming out, and then we just discussed, as you rightly described, circular economy. Waste does not go waste if we treat them well, okay, and the waste can be a raw material to some other industry. It is not an industry in this particular industry, some other industry, and which can be commercially utilized. Can you think of any such activity? Thermal? Okay, so How would you like to elaborate on that? What is the cycle?
So we generate energy in the process, like we go to fly ash and type of waste.
Correct.
So now like we are like we train fly ash for construction purpose.
For construction. That's a good example. Yes. Any other thing?
The CO2 produced in the thermal power plants and used in the like the soft drink industry, like the carbonated drinks.
I am not very much technically sound, but it is, yes, it looks good. And I was just, before coming to this class, I was trying to understand his research work, which is being done under a Dr. Saab pilot. So that is also a good thing, which is being put into this. So yes, something more which is very, very attached to us, which we are using every day or something we are doing every day. Okay, so water. Water may, almost all the industries, they require some water, and almost all the industries, they pollute water. Their output is the polluted water. Okay, so that polluted water has done what in our country? It's known to everyone. It's just for anyone to just come, like just have the, not the courage to speak, just an attempt to speak. What the polluted water has done in our country in the last 30-40 years?
It has handled the problem of the drinking water, the scarcity of the drinking water.
Correct.
And the usable water to be used in the agriculture.
Why this decrease in the usable water or the potable water has come? There are rivers earlier also, now also. That is the term I am trying to encourage you to come up with. Yes. So what we are doing is that when we have a polluted water, it is going to the drain, and from the drain to a larger drain, then it is to the river, then it is to. So everybody is getting polluted, everything is getting polluted. I am getting the scarcity, and then treatment of water with the normal water treatment filter plant might not be sufficient enough to depollute all the water, and then I am having a problem of how to finance the filter, how to finance all these things, and then the water is not reaching home and the consumer is not paying. So we are in a loop, and the loop which cannot be. What are the are you aware that there are attempts being done how not to or how to use, first of all, how to reduce the wastages and how to reuse it? Is there anything that is aware, that you are all aware? No problems. So let's see. So I'll just go to the. Yeah, bilkul.
Best example of wastewater, and so if you want, we can stop the camera for the betterment of our discussion.
Yes.
Don't mind me, it's not going live right now.
You can edit it later, yes, because this is.
What's happening? What is the politics behind this?
The politics is just nothing. Means there is this clean river program under Ministry of Jal Shakti, which is a special purpose created ministry after the present government came to the center. So Jal Shakti नामक कोई भी ministry पहले नहीं थी. वो थी Ministry of Housing Urban Affairs, है ना, under that water sanitation ministry, this thing, Ministry of Water Resources, Department of Water Resources, which is on the dam, the irrigation, all those things. So this Jal Shakti, and it was for the purpose of cleaning the water. And suddenly there are hordes, and that's where the policy. Good that you asked a relevant question, and I can now relate it to the policy. Then there was a policy designed. So first of all, do we all understand what is the? So I'll come to the specific answer later. I just got the chance of connecting the two things, so I'm just drawing this. So do we know the project life cycle for any project? Everything is a project. For me, everything is a project. Even I am speaking here, it is a project, or delivering a session for 45 minutes or 1 hour. Okay. So everything for me, it's a project. If family is a project, like doing anything is project. So for anything, the common sense is the most important thing that we should have. It is not the technical knowledge which is required. For most of the things, you require only the common sense. What is the first step? In any project, what is the first step?
Realizing our need.
Huh?
Realizing our need, what we need for the problem.
Good. So first of all, you realize the need. That's a perfect answer. After that need is done, then what do you do? So yes. So the first steps is the planning. Then what do you do? Planning is done, and I'll come to what are included in the planning and how the bottlenecks are coming. Planning, then you do the execution, financing of the project, and execution. And the third thing is, what do you do when the execution is on the ground? When people are doing the project, what do you do? Yeah, somebody said? Inspection. Yes, inspection. A better version of inspection is? So you do monitoring, don't inspect. Inspector Raj को जितना दूर रखेंगे उतना अच्छा होगा. Inspection brings lots of negativity. That's the difference between inspection and monitoring. Monitoring tells you what to improve. Inspection penalizes you and tries to find the fault in all the things. Okay, that's a basic difference. So I am not going into those things. So that is a monitoring, and what the monitoring does. And the hint is here. I am saying that it's a circular activity, and the hint is here. What the monitoring does, you all do it in your flow diagram, all those things which. Correct, absolutely correct. So this is a feedback. And fine tuning of planning. Now we reach to that this thing. Now comes the Yamuna river cleaning. So there was like rivers were polluted, all the rivers were polluted, and the rivers got very narrow. Some of the rivers, like Meethi river also, you go to Meethi river, nobody apart from you and me who are in Mumbai for last so many years, who would call it a river. If somebody coming outside will say Nala. Okay, so where is the river? River has a visual appeal, means river would be large or something. Even that has happened in Lucknow, where I come from, all the places. In Lucknow to Kanpur, if you go, there is a huge bridge of Kanpur के ऊपर, वो गंगा जी के ऊपर बहुत बड़ा ब्रिज है, उसका कोई फायदा नहीं है. मीन्स वो आधी से ज़्यादा तो उसमें रेत ही हो गई है. द गंगा जी है उसमें लिमिटेड है टू वेरी वेरी नैरो स्पेस. Earlier when we were very kids, we used to see water from end to end. That was the Ganga at that time. So that's where the water scarcity, that's where the cost items, and so the policy was designed. Now it is to be, pollution is to be treated. Okay, pollution is to be removed. Removal is not possible till the time we stop the activity. So it is coming out. It is but natural. It is given that the pollutant will come out. How to stop them further polluting the rivers or the this thing? We can put them into the, so the need arises, which is what you said. Need arises. Need is to depollute. Need is to treat this. So the policy has to come. How to? When the question is asked, how to, comes the policy. Policy for the expert things or the terms, it looks policy means बहुत बड़ी चीज आ रही है. For everything also we are doing policy. Okay. When he designed this course, it's a policy. When I designed this presentation, I decided, okay, how to. When the moment the question comes, how to, it is policy. Okay, how to execute becomes the execution. How to do the policy. Policy decides how to execute. Okay, so policy came. This was considered a cost item, and the government thought, and the government, because it is not only not giving me the potable water, but it is actually a health hazard, which is like if it is untreated water is being consumed by some people who are not able to afford a good water, then they are going sick, and our GDP is affecting at the later stage because the human resources, which is the very important resource, is getting sick or it is not healthy. So health is always a cost item. Government then came a policy that for every discharge of this thing, there would be an STP. So the sanitary, not the sanitary, sewage treatment plant. Sewage treatment plant would be in place, and for the different discharge, there would be different category or the different size of plants would be in place. So that's how they put. Most of the, what is the role of center and the state is the answer what he is asking. So the center is, if you all know, I will touch upon a constitution for a small, for a minute only or for a half a minute. Constitution gives the direction who would do what. Again, a constitution is a policy. So the constitution decides these items would be dealt by center alone. These items will be dealt by the state or the local bodies alone. There is no interference on the execution or this thing from the center side. And these would be, there are certain items which are in the concurrent list. Concurrent means both of us do. So most of the local level things, these are ministries are there, but they don't execute because they don't own that space. Space is owned by the central, the state government or the local body. So they created a policy. Policy always would have the incentive and the rewards and the risk and the penalties. So they said that, okay, if you are a pollutant, there was a 2016 solid waste management and the extended producers responsibility rules that they come, and they said that, okay, if you are producing pollution, you have to do this. I will treat, but I don't have a technology. So the government came up and then they decided. Then they said, okay, this is what then when I'm asking you to do something, when the teacher asks you to do something, teacher actually goes and teaches you first. No teacher would immediately come to the new class and start asking test, आज ही तुम्हारा grade तय होगा. ऐसा होगा नहीं. So it means that you are given incentive first in your own family also, in your own home also. You are given incentive first to study and then it is rewarded. And if you don't, then there are certain parents, yes, you will be sticked around also. So no problem. But then, so the government came up with the incentive. Incentive was in the terms of financial grant. Because it's a cost item, I'll share the cost. And then they said, okay, whoever takes this step, I'll give you this much of incentive. Okay. So waste management again, when we were discussing state and the center, there is also a third government, local government, which is a municipal corporation. The municipal corporation is a constitutional body without having a direct control of any center or this thing. They have their own elected representative. So I tell you the difference between, there is a difference between the government and the government agency. Any place where you find an elected body by the people of country or the people of the place, those are government. And any place where the officials are selected by the government, these are agencies, or they are not government. A government ruling is binding on the agency's own policy may not be binding on the other agency also, forget about the government. So small distinction, because if you have to go further in your life on all those things, these mistakes I have seen people keep doing. MSRDC, MMRD, and they are the government. No, they are not government. BMC is a government. BMC as the elected representative. So this subject which you have talked about was with the municipal corporation of Delhi, which was with the other parties. And the earlier, this is not a recent phenomena that has happened. That was an old practice. That was the old project which was in existence and the piling was going on. And the people were struggling. I have worked on the waste management projects for almost maybe I would have touched maybe more than 20 or 25 projects in decision making. Some were closed, some were inquired by me maybe, or some are doing wonderfully well. Okay. So at that time, everybody was coming. When these things, when the innovation comes, everybody come with their own set of innovation and they will start trying everything without any field trial. In India, we are very poor in the research and development.
How to break this nexus and start maybe creating some startups for the young people who can
Oh, that's very wonderful. Very.
and do something interesting, because otherwise these three bodies will be there and
Yes. So the first thing first, I believe that's what I have done in the Indian Maritime University when I drafted a PPP policy for them. Try to engage with the industry and the players on the ground, because they will tell you the bottlenecks, they will tell you their pains, okay, and that would give some of you an idea how to break this. So that's a cycle, that's a chain, and that the chain has to be developed by the people like good institutions, and who better than in India now that I am standing here. Means IIT Bombay is one of the best institutes that we have. So you have the startup policies. I have seen the innovation center also. You have those incubation center also, and there are so many kids who are doing wonderfully well in this thing. I know somebody in the water sector who has manufactured a wonderful robo which goes under the ground for 500 meter here and 500 meter there, so he can cover with the same remote 1 kilometer or distance, can pinpoint if there is a problem in the structure of a pipe, which was till now is huge cost item, because you have to dig, put the person or something or some rollers and then keep digging every 10 meters or 20 meters or 50 meters. Okay, I am having some little time, but before that I will complete my some of these things. Okay, so I am going to tell you. Yeah, so I am. So let's concentrate on 5-10 minutes only on this, because this is a classic example of the circular economy and how the waste is reutilized, and this is a perfect example of any planning, project preparation, feedback, monitoring and everything, and I have seen it by myself. So it is a first hand this thing, and I have taken some photographs when I was there, and I've used this, and this is what I've done today only. When I said that I'm preparing my speaking points, these were all. What is GIFT City? GIFT City is the Gujarat International Finance and Tech City. So they are they have done some kind of a area where they are doing only the buildings they are designing, and the buildings are just the plug in and plug out. So you go with your files, you go with your data, your laptop and everything, you just start doing everything just tomorrow. You don't have to build infrastructure. So the infrastructure is being done by the government. Now what the best part is, they don't have any overhead wires. So everything is underground. Okay. If everything has to go underground, I don't know about the IT, but if it is to be done, we have to do the replanning. The planning was like somebody is seeing the future after 50 years, somebody is seeing this future after, let's say, 20-25 years. That's a planning. Okay, and that's how you see, like the municipal corporations, DP or this UDCPR, they come up for the plan in the city for the next 20 years. Okay, that's the plan. Plan is only for 1 year also, but the long term planning and this. So they went ahead with the long term planning. They went ahead and they did everything. First the first plan, and then start structuring, and then put the structures in place, what the plan would be. So they said we will do a forest management. So it's a kind of a city in forest. That's an urban forestry. It's a city in forest. They have 100,000. They have planned it for 100,000 trees, almost in 280 acres. I think my Yadash is correct. 279. Okay, 1 acre can be granted. So 279 acres. So this is what they. So what will it do? It will create a green environment. Okay, because they know that they are doing a concrete structures coming up. So the heat element is going to go there. How they are mitigating it? Mitigating by planting 100,000 trees. And somebody would have done the economics also. How much carbon is generated by these many building structure, and how much carbon would be consumed by the trees. And I am sure that somebody would have done it. So I leave it to that. Solid waste management. You just can't believe the kind of thing I have seen by myself. And I'll show you those pictures also. So they first of all they did everything under the ground. And under the ground they have not done only for the electrical wires or the water pumps. No, they have gone ahead with the cooling system. They gone ahead with the they go down 2 floors below, and then they have laid the pipes for everything, even for the solid waste management and the wastewater management also. What they have done is that they have the plant. So I have seen in the office, when I visited their office, for every office there are certain corners or certain midpoints where there are cylinders for different types of waste. Most of us have started segregating. It has reached to 70 to 80% in most of our societies, but yes, definitely. So there it is an office environment, because you don't have a house over there. In GIFT City it is all commercial. Okay, it's all the businesses which are doing. So they will go, they have the coffee, trash, they have everything, they have the plastics, and so they have 3 bins, and they'll put the bins into this. Those 3 pipes go deep down to the second last floor, or the 2 floor down the earth, down below, and then there are suction pipes which are now collecting this kind of waste which is coming from all the buildings and connected to the pipe, the major pipe, and the major pipe is sucking and putting into the plant, and the plant is underground. Plant is somewhere, means it is connected with the underground, it is treating. What happens to the treatment? Water and waste management. So they have a zero discharge policy. You just can't throw anything out, but you will have to throw. Again I am saying, I am not saying that don't throw anything, I am saying throw it responsibly. So I am not changing the basic need, I am trying to change the behavior towards the sustainable environment and financially viable projects. Okay. So zero discharge means GIFT City treats its water and the recycled water and non-potable. What is the benefit to the by treating the wastewater? First, rivers are not polluting, that we have discussed. What is the second? Very important. Rivers are not polluting doesn't mean we are earning money. Now we have a drinking water, but it's a cost. And that's where the government has come up with the incentive scheme, subsidy also. Okay, viability gap funds are there for up to 60%. The government gives the capital grants. Now, what is the other use? Why the wastewater should be treated? Why not it should be treated to some extent and then flown into some areas which is not polluting or which is not creating a major pollution? Why it is treated to reusable manner? Because then because they have the tertiary plants. There are primary which reduces, Dr. Saab know is better than me. There is an environment section here. I work with many other professors in various committees. So those people know much more than what I know. But yes, there are BOD and those levels they are reduced and those impurities are reduced. And as the technology goes higher from primary, secondary and tertiary, the cost increases multifold, exponentially. But it reaches to a place where I can drink the water also. There are scientists who go get the water from the tap and in front of you they will drink to prove it is perfectly all right. Why do they do this? Why do we do this? Why do have more cost when it is only a water which is treated? I could have done with resource conservation is yes, but conservation, yes it is, but I'll ask them to come up with the more, yes, please go ahead.
Probably if it goes untreated, then the cost of the diseases that would come along with it, that would outweigh this cost.
Which one?
Like if there is the water goes untreated, it will cause some disease.
Okay, so I take your point. It is again adding to the cost or reducing the cost. It does not produce a sale. Till the time a sale is produced, I am not going forward. Country or the family or individual grows by earning. It is not by saving cost. In your life, try to earn more than you try to save. Okay, saving does not help. Saving helps you prepare for the future eventualities, and you must do saving. There are books written 30% should be saved first and then rest to be spent. Yeah, please go ahead.
If the water is of drinkable quality, then you can sell it. You can sell the water.
Yes, exactly. Because if it is for the non-potable purposes, I can use this water and sell it as a lower cost and encourage people who were using for their cooling system, for their non-potable things, for gardening, for taking the water to the gardens, for doing anything flush. There are societies in maybe Navi Mumbai or maybe, but I have seen in Pune at my co-brother's place also, there are 2 pipe systems. So it is one drinking water pipe and one which is flush water type. Okay, they don't have the pipe in going to the kitchen because we are not mentally very strong or not strong but mentally not adaptable to the. We'll always say, इसमें से कुछ तो बास आ रही है. Yes. So and then they will say this water comes at a let's say 50 rupees per kiloliter, but I will charge you only 20 rupees per kiloliter if you charge me So I have now recovered my cost to the extent 20 kilometer can suffice, and then there is a grant. So maybe the grant and this thing, and that is a part of policy. What is the part of policy in this? If somebody is actually listening to or attending to this thing, he can catch or she can catch. What was the policy part in this? When I said that okay, I have done this arrangement that I will do the treatment to the tertiary level or maybe secondary level, which can be used for the non-potable, and for the non-potable the lesser price would be. So the bottleneck was it is only a cost item, and the policy part has resolved it. What? That is one. Yes. Correct. Selling part and deciding on the price. Policy decides the price. For some of the things for which we can't survive without, okay, like water, I can't survive without a water. I just can't leave it to the people in the private sector. Okay, road, you have to do a road, so the government decides the toll. Many of you might not be aware, wherever a monopoly is created by the law, there are certain sectors monopoly is created by law. Toll road is monopoly created by law. There cannot be any other road parallel to that connecting same A and B. Okay. Okay, there would be some market dynamics, but he can charge, let's say government has decided 800 rupees, he may charge 1200 rupees. You and me will never be able to know. Government comes in. That's a regulation, that's a policy. So the bottlenecks are that, like you have asked me to keep touching on this thing. Bottlenecks is how to price it in a manner that it is not pinching, it is win-win for both of us. We should not do anything in our lives. That's what my learning is, which is a zero-sum game. Zero-sum game is only a flash card game. Somebody wins and somebody loses. Exactly same amount. You always have a zero-sum. So it means that all cannot go happy home. But the positive sum game leaves everybody going out of this class, out of my home. If they all are happy, everybody goes home happy. So the policies try to attempt this, everybody going happy. Somebody who is not happy is a culprit. He is an accused of doing something wrong, and for that policy, again, policy not only sees how to encourage this, policy also has to write provisions. If somebody tries to manipulate, somebody tries to misuse my policy for his personal gain, how to stop him, how to put a penalty into it. So both these things are the part of policy. So the policy makes this thing, and then water would be this thing. Other uses. If I am having 100 mld water and my city demands 120, I was anyway 20 mld shorter, and this 120 required the gardening, required the flush or something. Now 30 mld or 40 mld was for the other purposes. Now I have started putting 30 mld water into the system. Now the 90 water is 90 plus 30 is 120 available now, 100 and let's say 130. 30 was required or 40 was required for non-potable. My drinking water increases with the same cost. So the people are getting benefited from both these sides. Now I am not having only 2 hours per day intermittently or when it comes, but I am getting again a policy part. Now I am getting on a regular time interval, because there are people who are managing the water better with the time management, and I am getting at the regular interval better water, not the better means the better quantity of water, more water, and my needs are fulfilling to some extent or to a better this thing. So that's how waste and wastewater management was done. So they are aiming 100% of his wastewater to be treated, and I'll tell you what they have done. So they have a cooling system. Okay, this is very interesting. This is once in India. I think I have seen it for the first time. I met a Gulf country, some very good sovereign kind of a company, that is they do the district cooling system. What is district cooling system? We have an AC here, okay, so we can take this example. This AC, how is it being run? Who is running this AC? What is running this AC? Electricity. So you have electricity and you don't have solar, so you have thermal, okay. So it means that you are emitting pollution in the environment just by having this cooling system, and that is the energy part. Then it is throwing the bad air outside the environment, which is again this thing. So my energy consumption is increasing because because there is a heat, because of the concretization outside the atmosphere, climate change. I went back to the room. Earlier I was satisfied with a normal fan, now I can't satisfy myself, so I require AC. AC added to the same thing which has created this need. So it's a spiraled this thing, and we cannot come out of this thing. Now what is the other option was solar. The solar may not be, solar is being used extensively in India, wind energy, and there are renewable energies which are coming in place, and for that government also has come up with the policies and this thing, they are thriving. What is the other option? There is a district cooling system which you again would not be knowing, is that I will put water into the pipe and put a force. So that goes with the force in like a 90 km an hour types force, which goes back to the top of this thing, and from there are air nozzles or something, means I am not able to correct the correct word, but there are like this blowers only, and that blower is actually taking cooling from the cold water which is being thrown in the system, and that cold water was generated by treatment of wastewater. And this system works on the 60 to 70% lesser emission. I think it reduces 30% emission, and it is producing lesser this thing. I think this requires, and the water and the cost also, this does 1 ton of AC requires 1.5 to 2 kilowatt hours unit, 1 to 2 unit. Same thing, it is being done by something 0.9 or something by the 0.8 to 1 kilowatt hour by the district cooling system. So, you are saving on the units. If the units are being saved, means that I am saving the lesser emission, means I am sending the lesser emission to the this. So, that is a carbon part, and that is this part that I am not only saving, I am on the cost also, because I am now paying lesser cost. So, it is making financially viable. And whenever I am saying, you may be visualizing. So, I have this photographs, these are my personal collection. So, this is the city has a master plan like this. So, this is where the planning comes. I have not done even an inch of a brick without getting this plan approved and without getting this plan in place. And this plan is not for 2 years or 2 buildings, it is a plan for a city. A similar city is coming up in MMR region in Penn, Raigad, Penn, some growth center is named. Earlier name was the Orange City. It is being done under a public-private partnership, where a private sector money is being utilized to structure the city. Okay. And the cost would be coming from there, and he would recover his cost by selling the better plots and the infrastructure, better usages. So, this is the city master plan. This is where the district cooling system is there. This is the city. Okay. You can see it's only the buildings which will be shown, and at that time I didn't know that I would have to use it for a session. So, I have lesser buildings. So, this is the best I could gather. This is the district cooling system. I went there. Within that district cooling system, the first thing you see is the master plan, how to manage the and this is 2 floors below the ground. So, that is how everything is there. This is the underground duct. See the height. Okay. I have attached a photo of mine also, just to give you the height or the aspects of length and height and this thing. So, this is where these are all the pipes. What are these pipes? Just see this. This is potable water, this is solid waste. Everything is flowing under the ground and connected to all the buildings. There is no pollution coming out from the building. Everything is there. And there are treatment plants, there are city level, like the city level fire water. They have this system also. In case of fire, what happens? So, I am not using this water, I am using my extinguisher with the use of non-potable water also. No problem. Okay. Just to give you the idea, these pipes, and this is the duct which I just sat down on the ground, on the floor, and I tried to pick up this thing. So, again I did not have the idea that I would be using it some session. So, whatever the best I could, and they go huge, means they are kilometers long, they are under the ground at every place. Okay. That is what the city of Holland has done, Netherlands has done, because they are pumping with the rainwater. They have the problem of drain. So, drain system is so strong, and they have the problem of flooding every time. Their city levels are below the mean sea level. Okay. So, every time the water comes, they are flooded. What they are doing is that their ambassador told us that they are sending it to the other, they have created lots of water bodies, and they are pumping from one place to the other, and the water bodies are created where where they can maintain it. Similar things are being done here. This is huge. Just see. Okay, it going deeper and deeper, and there are kilometers, and they have done very successfully. Best part, the planning has come, the energy execution and the financing has come, monitoring. They have more than double of this size, something, or maybe 1.5 times. Don't go the size aspects. They have a huge command center where they are controlling each and every element of the city which was planned. Okay, and this is in our country. This is not Spain or any foreign country that we are used to most of the time, and there is another city which is coming up just like that. There are cases where you can see, because of the paucity of time, I may not complete all the cases, but these are only 1 or 2 sentences. So, in not only this, there is a Gorei plant. Okay, in our city, there was a waste management plant. On that note also, that the ILFS was given. I just I think I just left it in between the daily discussion. So there was a huge heap of this thing, and when it becomes huge heap and without any treated waste, you are not treating the waste, you are just dumping. When you are dumping, there are methane gases, there are gases which are burning, and when it starts burning, nobody touches. So a problem not attended at the first time becomes so big that you just can't do the things possibly in the time that is required. You take lots longer time, because the problem is also of a longer time. So you take longer time, you take more cost, all those things. The cities are getting aware, and now they are trying to do the mitigation. Why it was not done? People tried various technologies, okay, at that time, and those times the technologies were being imported, and there were some who were trying indigenous. They did something and they failed. They were successful, like there is a company, I will not name it for the purpose of proprietary of their, and they name, yeah. So they were successful at one place, a small city near in the MMR region. They miserably failed in Pune. Same technology, everything same, because they did not test on the how the increase in waste suddenly or the character of waste changes, what happens to the furnace. Every time they put the furnace and the furnace got blasted. Okay, they couldn't sub. Just 2 days back, I was talking to a good person. Good person means a good company which is doing lots of good solid waste management projects. I asked him, how are you doing this thing, or there are some other wire. So there are MRF, you are doing material recovery facilities. Circular economy, you don't do any waste, you reuse, recycle and put back to the economy. That's a circular economy. So he is doing, MRF is same, material I will recover and then the dry waste will go to the furnace. But he is actually now putting some wet waste also. I asked him, hey, this is against the law. He said, but this is the most practical, because when I am putting the RDF, which is the refused dried fuel, then it is then the temperature of my furnace goes to 1200 degrees, and then this may go blast. I have to contain it at 900, for which I do need impurities, and that is something which I have just heard 2 days back. It is correct or not, I will be talking to the scientists, but this is what they are doing. So this is where the innovation comes by the use, and that's how we would be reaching. Like Pimpri is being seen by Honorable Prime Minister also, and he said that this is a good plant. Pimpri Chinchwad. Oh, sorry, Pimpri Chinchwad. So there it is. So they are doing. It is not that everybody is failing. With the failures, you learn and do this. So this has. I would request you to just give this circulation to this thing. This is what I was there. Thank you. So you can see the kind of depth they have, and in 2D picture it is still difficult to gauge. I would request, if the funds allow, GIFT City is more eager to have more visitors. First of all, that gives the advertisement for them, because they want to promote their city to get business out of there, business inside there. And this is a classic example of whatever we tried to learn today in a short span of time. This is what I tried when I was just thinking in the past 2-3 days that what should be done for a small time of 40-45 minutes or 1 hour. Finally, in the morning 11 o'clock, something stuck to me. Okay, let me do my GIFT City presentation. Let me take you all these aspects, and I think all these things are covered here with and this requires, you all are doing, means a best of the best course, I can say. Geotechnology is the arm where you are studying soil, rock and everything, and basis which what depends on, every structure depends on that. You study the rock to see whether it should not tilt, it should not fall down, it should have and then the earthquake also, all those things. So this is wonderful, and if you understand how to include the environmental aspects profitably, this is very important. Just don't do it because without any cost, without any profit into it. Health and education, yes, these are because they are producing better manpower, and the manpower is the biggest resource you have in any country. Okay, if the country like India or somebody is having the best manpower, intelligent manpower, healthy manpower, I can do anything, wonders. The country can do wonders. Thank you very much for patiently listening. Thank you.